Okay, so first off, this tool is, not very robust. It's not particularly robust. It's very finicky with syntax. It's definitely not fast. I don't even know if there's anything I can do about that. It might just be that a lot of the time it's just startup time for whatever, because run times it has to do. But nonetheless, you'll see that it can be pretty useful for certain things. I actually, for my main project, what I'm using is the Python tool called 𝘏𝘏, which I have a slightly modified version of it. But a lot of what I'm going to be showing you is stuff that I've also done with with a very, very similar tool for Python, except this thing I made actually has a bit more features than this tool for Python. Alright, so the most basic use case you have for it is you just, within a comment block, you may use this comment and this special comment, and then have this special comment, and then the code inside will execute. And you return a string value from inside of it, and then the string value will actually get inserted after, between this special block and this special comment, right? So you can also do this as, you can also have the code be inside of a single line comment. So that's a pretty nice feature. Yes, I do. Okay, so there's also a thing like a one-liner, right? And so that is basically I'm just outputting, this is the only code, right? And I'm just returning this as a string value. This is the same thing as if I typed return foo. I'll go ahead and save that. And I'll run it. What's going on? But okay, so that expands out into what its string representation is. And so this is all a separate runtime that's happening, right? I'm using C#'s scripting API. What else can you do? Okay. So you can define functions and you can use them later. And you can also have a block that doesn't return a value. See right here, there's no return statement, there's no variable at the end, so it actually doesn't output anything at all. There's a number of built-in variables. One of the built-in variables is called Whomst out, and it works just like console. And so you can write out variables with it. And so here's the function, use Whomst out. And we're going to, have that function get called, and then we're going to return this string. So let me go ahead and get that code generated. All right, see, went ahead and it ran that code, wrote the line x++. All right. All right, so you got this thing, got the thing. Oh yeah, okay. So here's a little weird thing, is you can have a yield statement and it will actually separate your code into multiple different blocks. So you have this line gets yielded. It works sort of like it works like an iterator a little bit, but it's actually it's very much hard coded. And it actually is based on what line it's on. But anyway, so first it will output this, and then then as a separate chunk of execution it will run these two. Okay. So it outputs this code. Very, very nice. All right. What else do we got? So C# script is kind of a superset on top of C#. I don't actually know all the differences, but you can load assemblies. Anyway. Alright, so you can load an assembly using #R, but there's also #load. I don't know, you have to look that up. C# script. So by default, Whomst will include some useful assemblies like dynamic types, and regex and things like that. Very nice. I'll go ahead and run this code too. All right, so there's more built-in another kind of useful built-in variable is you can get previous content lines, and it will actually look at what was the content of the document, the non-generated content that was between this block and the last block, right? And it will go and collect it, and it's right there, and it'll say how many lines was that, and it will say how many lines it was. Well, that's if you're saying .count. In practice, you use this for much more interesting things. But I'll show you, like, if I were to go ahead and add extra lines here. I'm really selling you guys on the ease of use here. But no, but like, look at that. Okay. Anyway, so then there's some other stuff you have available to you. So I'm having this like output a comment with all of the sort of utility functions that I have included. So you can get previous content lines, previous output lines, previous code lines. You have a dictionary with definitions that are like included in a JSON file. You have your output writer. You have any value. I'll talk about this function and this function I'll talk about later. But you also can get the previous content, previous output, and previous code as strings. That's really the important stuff. Okay. So there are some other properties. Oh, okay. So now here we're getting into the cool stuff. So I have this block of code. So between this block and this block, I have this statement: const float pi equals 3.14159. Right? And what I do is I have as a yield statement, I'm taking a string with that dot text that was between these two blocks, right? And I'm actually like evaluating it and adding it to the state. So it actually will go ahead and it takes this and it's actually like adding this to its code, right? And then it is going and taking pi times pi and it's outputting it and it's going to make it into a constant. So then finally, from within a file, you can tell Whomst to process another file using Whomst load. This will pre-process the file and it will add anything defined in that file will get added to your own execution state. So we have a thing called define variable right here. So it's going to go ahead and define this string named string defined another file, right? It'll output it, but then that variable stays present, right? And so when this gets executed, it will actually go ahead and put that code right there, right? That's all generate. All right, so we got those basic features understood. Any questions so far?
So is it kind of like compile time execution kind of stuff?
Yeah, it's compile time execution. That's right. So it's a little bit like the C macro preprocessor. It's a little bit like the template preprocessor in C++, but it is written in a very, normal, easy to understand language, right? This is just C#. Like if I were to take this out of this comment here, and I were to paste it right up here, it's just C#, right? Except this type isn't defined in right there. And then also like this is just a string literal with no semicolon after it. That's the only differences. It's just like that's just a syntactical convenience. But you don't have to use that at all. You can just go return semicolon. And maybe I should have actually done that just to make this thing like, I don't want anybody skimming to the middle of this thing and thinking, he's made something that's too hard for little old me to understand. But anyway, okay. A lot of the use cases for this are the same kind of use cases you could have with just like the C preprocessor, right? So you could just have like var int function name, you know, you got like f name is equal to get int whatever, I don't know, get int, and then you know, somewhere later on you have a thing that's called int z is equal to do not indent my code. Use Sublime Text to type this generally, but there's some I wanted this syntax highlighting I can't get with Sublime Text. But anyway, so yeah, you know, that's you can use it just like a regular C preprocessor. But let's do some more interesting stuff. So let's go look at interop here. So very importantly, this is not restricted to being used in C#. In fact, I have consciously made it so that like you can pick whatever kind of syntax you want. It's in a configuration file. So like if you wanted to do like shell scripting, you actually can in fact do something like could do something like have a comment block that looks like this, and then you say like you know, you say something like you use triple parentheses. No, you don't want to use triple parentheses. You want to use like quadruple square brace or something like that to start a block, and then it just works the same way, right? I don't actually show that, but it works across languages. And one particular instance where that is useful is you can use it across C# and C++, as you often have to if you want to make like a Unity game. Wowee. Okay. So here we go. So what I'm doing here is I am taking this chunk of code, and then I am evaluating it. So I'm actually adding the struct into my own cache of types, right? Then over here, as I am using C#'s reflection system to actually get the names of the fields within the struct. You know what? I feel like I'm giving away the surprise too much if I leave this all generated. So let me go ahead and I'm going to zoom in a whole bunch so you guys can't see it. Woo. There we go. Okay. So over here, I take in the type. So I take the type and I go through all of its fields, and I output the names of the fields. And in this particular case, it's really easy because they're all types that exist that are portable across C# and C++. In other cases, you'll want to like have a name replacer for things like, oh, you know, if it's an int ptr in C#, you replace it with a void pointer in C++. How it works in my real serious project is I have basically any struct that goes to C++ code. It exists in both forms, both in C# and in C++. And that's very nice, and it's really not hard to do. So we go and we actually like declare it, and then I also have a thing for you to add function signatures into a list of strings. You take very easy. And so over here, we start the declaration with one of these C macro API things that, you know, is actually like decal spec. And we have the function signature right here. So that's going to get added to the list, and then it's going to get output. And then over here, we're doing the same thing. We've got a little utility function for indenting. This is a verbatim string in C, a multi-line string. We've got a little tool for formatting multi-line strings and having them indent properly. but here's another one. Oh, and then up here we are outputting the struct. So let's go, let's see what happens. All right. So we've got the struct here, and it's packed just like it is in C#. That's actually not something I did, though. I don't want to take credit for that. You just should always pack if you're having a type be portable across two different code types. But over here, we go and we've taken the function signatures and we've also included them in our C# code. Now, if you guys have ever done interop between C# and C++ code, you should know that it's a big pain in the butt. And this makes it a lot easier. The exact same, like anytime if I were to go here and update this function, right? If I okay, let's say I wanted to add a thing here, which is public float move speed, right? And then over here in this function, which is move armies, I have a float delta time. Oh, you don't want to type it there. Oh, this is as good a time as any to show you guys. Float delta time. If you accidentally edit this part, which is actually output, the thing won't actually like override it. Unless it does. It's not how that's supposed to work. I got owned. But I'm gonna have to look at that. But the reason for this hash value right here is so that you don't. This is a hash. This is a CRC check of what is inside of this, right? And so like before it overwrites it, it actually like checks, gets the CRC hash of this and makes sure it is the same as what was written down, and that prevents you from like accidentally overwriting code that you wrote in the output area. As you can see, it adds this. It adds the float delta time parameter over here. I have float move speed, and it goes ahead and adds that over here. This single means single precision float. It's actually up here. Excellent. Awesome. Great. What's next up here? Dependency injection. Maybe I'll skip this one. We're going to skip and go to serialization. All right. I'm going to zoom in so I can clear it. All right. So a lot of serialization systems in C# rely on runtime reflection, which can be quite slow. So what I mean by this is you have a thing where you go like type of, and I don't know, we have something like I'm trying to think what's like a really basic built-in type. I'll add a dependency on like system.windows. Do I have input? Is this I command? No, I don't want that. System dot web post permission, like whatever. Okay, but what you can do is you get a type, and then you can just like do like get fields. You can do get methods, all that stuff, except you shouldn't do that because it's really, really slow. And if you're like doing it in like an inner loop, it's gonna kill your performance. However, if you want to do that at build time, that's absolutely fine, right? And so you can make a hard-coded serializer using the same information that people use everybody else uses to make a soft-coded reflection-based serializer. All right, so what we're doing here is we're just we're calling output serializer for the RTS enemy class. Then we're looking at the type, and then we're just once again like going through its fields, and we're passing it into this fictional fast serialize method, right? Where like in an actual situation, we would have fast serialize for like ints and fast serialize for strings and things like that. Okay, so let's go ahead and generate there. So there we go. It goes through all the fields. Oh, and it even tags them. Wow, amazing. Fantastic, yay. Okay. But other uses you can have is if you want to have like a function to clone an object, make an object that's an exact copy of it. This makes that easy. You can generate two string methods. You can make your get hash codes. You can have your equals equals operators, stuff like that. Let's do another one here. I'll do one that's in a similar vein. Is card game. So a problem you run into a lot is like you want to have a thing in your data like this defined as being a variable, right? So you maybe make a static variable. This is the fictional scenario here is it's a card game, right? It's like Magic the Gathering. And you've got a name of a card, you've got the power, you've got the toughness, and you've got some enum value, which is its ID. But actually, like down here, we can see that the enum value is totally blank. You know, a frustrating situation you can run into is you've got a card named Knight, right? And you know, you go new card, and you say its name. You have to type Knight twice. If card ID has some value, like you might go like ID equals dot Knight, and then you know. Power and toughness, you just have to assign those, but yeah. Okay, but if you might run into a situation where you like want to go ahead and rename this to be something else like samurai. And then, oh, you know, I forgot to rename this part of it. And this name does not really exist while your code is running. So there's, you know, you're not going to notice it. It's really hard to notice that kind of a mistake. So how do you get around that? Well, it's pretty easy. I use reflection over here in this example, but you could really just do this with like just a regex, like looking at this string, the string from here to here, right? And you can just spot, you know, okay, whatever comes after public static card, that's the name of a card, right? And then you just generate code to go and say tortoise.name equals tortoise, snake.name equals snake, lion.name equals lion. So we're going to show code that does that. Wow, amazing. Ta-da! All right, great. Similarly, I went ahead and generated values for the card ID enum. Now they all have values, and now they all get their ID values assigned. Neato. And then also I fill up a static list of all of the cards. Although, maybe a dictionary would have been better. Anyway, okay. Any questions?
I'm good.
Anyone want to test their comprehension by attempting to summarize what I've demonstrated so far?
So you're running compile times C#, right? This is the main idea.
and you've given it access somehow to it passes. I guess C# has eval now, where you've exposed the parsed file to Roslyn or the compiler. You're getting the type information. You can just export it again in different forms as needed.
Mm-hmm. So a lot of the time, you want to have your functions be configurable into different behaviors with enums. All right, so you've got a function called eat_Reese's, which it takes in a Reese's technique, which is some technique that people use to eat a Reese's peanut butter cup. And as you know, there's more than one way to eat a Reese's. The thing about this, though, is that if I was to go in and people are kind of reluctant to do this because it involves a lot of context switching in what you're doing. So you're typing out your code, and you're thinking, there's actually another technique people would use to eat a Reese's. Which, by the way, this is kind of annoying with IntelliSense, but what's another way people would eat a Reese's peanut butter cup? In ice cream, and then you write the code for that, right?
Sure.
And you, okay. Somebody puts the suppository Reese's cup. We'll put that too. All right. Case. I aim to please. All right. This is technique. This is up the exhaust. All right. Anyway, break. Okay. So we got all these things coded, and I never had to go back over to add the thing into an enum, right? Which I would have to. I'd have to keep switching back and forth, or I'd have to be lazy and have my function be configurable in some less clean way, or I might be tempted to go ahead and lump some of the meanings of the different enums, right? I might say, eating Reese's and ice cream is also eating, kind of like eating two at a time. I'll just have them have the same behavior for this part or whatever, right? Or I won't make a new enum for this, right? It seems like a small thing, but it's psychologically taxing to be switching between two different things, especially in a complex function where an enum is the most useful. So let's let's make it so that we actually generate enum values, from just looking at a function. And there's really nothing fancy here. This doesn't use C#'s reflection capabilities. It actually just uses a regex that it searches for the enum name followed by a dot, and then it picks out the next words. It just captures that, and then it just outputs it into a list. Okay. Let's show a really dumb one. This is optimization in C++. So this is just, I just copy pasted this. This is not code that has actually executed. But over here we've got a function which is it's like the quadratic function, but it's for cubic functions. So it's like ax squared plus ax cubed plus bx squared plus cx plus d equals 0, right? It solves that. Boy, it's a big mess of code. But anyway, so there's a lot of mathematical operations here. And a lot of the time, the generous C compiler people will make it so that if you take part of a function and establish it as const, it will actually run faster. So I don't actually have any hard evidence here, but I have a feeling that if I were to take, say, Oh, this is interesting. Why does it only have ABC? What? That's weird. Whatever. Anyway, okay. But if I were to like take this away as a parameter, and I were to make a const double, cancel, b is equal to 3.0, I would probably have a faster function, where I'd say like b is 3, right? Okay. And then the optimizer can take advantage of that somehow. However, it's really hard to like take code that exists in something in C++ and like add those specializations. And it involves a lot of template nonsense, and the templates are like a whole different language. And it's silly because this is actually going to be like the simplest code example I'll show you. Basically, I have a block here. I have a block here. I capture this, and then all I do is I just paste it here. I paste it here. I just paste it in these two places. This is the function assuming a is 1. This is the function assuming c is 0. Wowie. Amazing. And so the way that people would do this in C would be to like maybe have the code be in a separate file, and then like you do an include right in the middle of a function, and then you like can copy this. But that makes it really hard to step through, so I don't like it. It doesn't play nice with your IDE. You know, maybe you actually like... the other thing that's really nice about this system is, like, let's say I decide I don't want to use this generator thing anymore. But I still like the code that it generated. Like, I can just get rid of it. I can just get rid of this part. And then I have code right here. Think about how difficult it is to... change a class back from being a generic class. Something like that. So then we've got over here, let's do composition. So composition is a way of setting up your objects so they're like made of a combination of a bunch of different objects. So we've got these interfaces here. Eye gun, eye legs, eye sword, eye head. And these are all like supposed to be parts of one larger object, right? That might have them interact with each other or whatever, right? And so, I want to have a class that inherits from each of these. And I have already existing implementations of eye gun. I have an eye gun made. I have an eye legs implementation made. I have an eye sword implementation made. I have an eye head implementation made. And so, you know, what I can do is I can pass it a list of these interfaces. And then for each interface, it makes a field, and then it also makes it makes it so that a class implements this interface, and then delegates the interface implementation out to some other object. So we're going to make Voltron right here. It's Voltron, except it's only 4 robots. Alright, so anyway. So yeah. So it's got an instance of iGun. It fulfills iGun's shoot function by calling upon its instance of iGun. Same with its, same with all these other ones. So if I were to like get rid of this, I would get an IntelliSense error because I'm not implementing the interface member iGun. All right, and then like let's say I want to decide I want to add one more component to this, right? What's another thing that a robot has? Wings. I don't know. Actually, I've never seen Voltron.
Long time ago.
All right. Bool can fly or whatever. I'm cheating a little bit if you guys can't tell. Like, I'm not using, I don't have parameters in here yet, but it's not that much more work. Anyway. All right, so we're going to add type of. Wow, it adds it. Amazing. Okay. All right, very last usage for this is it's really good for getting around limitations of C#, in particular, its template system. So I wanted to have, this is a real example from, with some details trimmed out, from a thing I actually used my Python meta code generator for. And the situation was, I wanted to have a thing that behaved like a C# array type, but it was actually heap allocated. It was allocated outside of where the garbage collection would ever look at it, right? So I go and I create a pointer to, this is basically just calling malloc. And then I assign what the length of it is. Great, fairly standard so far. But here is the tricky bit. If I want to do indexing, I have to be able to read a pointer. I need to be able to read a location in memory and convert it into whatever the generic type is, right? And I need to be able to take a pointer and write whatever the generic type. I need to be able to write an instance of that to that spot in memory. And something like this is only meant to be used for things that are called unmanaged objects. So that's things like int, not interface. That is definitely not one of those. A char, a boolean, but also like if I have a struct and then everything inside of it is also an unmanaged thing. So unmanaged. So if I have a struct like this, int x, char, c, RTS enemy I could throw in here, and that's still an unmanaged struct because RTS enemy is also an unmanaged struct. As long as you don't refer to an object in any way. So anyway, going back over here, if what I can't do, so I can't do this, is I can't take a pointer and cast it to a T* in C#. You can do that in C++, you can't do it in C#. And that stinks. But it's pretty easy to work around it. Just make an abstract class. You leave these two parts undefined, and then you have those get defined and implemented in descendants of the abstract class. So let's see that in action here. So this is really simple, just find and replace as I typed up a template, raw array underscore template. It extends the raw array class. And then, whereas where I was trying to use T* before, it is just going to do a find and replace with the actual type. So here we have a raw array of RTS enemies, a raw array of ints, a raw array of floats. Easy peasy. But some other examples of things you can't do with C#'s generic types. is you can't like have the dimensional. You can't have do anything like recognizing the dimension, the rank of an array. So if you have a 2D array, like can't really figure that out. You can't if you have, you can't have something like T arithmetic, which is a type you can do like, X plus Y on. Doesn't know how to do that. And then, of course, it's really hard to do things like generate vectors with a different number of variables. Like you can't have a size 1 vector, a size 2 vector, a size 3 vector. I guess that is it just about. So, okay, I'll talk about a few other kind of, these are a little more pie in the sky, but it's basically like what I kind of want for the future of computing, man. Let's go here. So this is like I shouldn't have it like this. This is just, I have here like an invented language, but it's styled quite a bit after like something like Prolog, but there's other things like reactive, declarative programming languages, where you are saying, you are providing it with a list of rules, and what it will do is it'll create code. It'll compile a program that actually like enforces that set of rules. So here I'm doing, this is like the board game Agricola. So you have 16 fields of different types. These are like things that the player has under their control or whatever, right? You have some number of sheep, some number of cows, some number of pumpkins, some number of grains, some number of breads. You're either using the oven or you're not using the oven, and then you've got like some number of goblins. I don't know. But so like this might be a rule. The definition of whether you're starving is this sum, whether this sum is greater than 10, right? And so what a lot of these declarative systems will do is they'll set it up to be like, okay, when it feels like you're assigning a new value to sheep, you're actually like going and you're calling calling some internal function called sheep changer, right? And it's got hookups to everything else, everything that sheep affects. It's pretty crazy, but it's quite interesting. But it's very kind of, it's really unlikely to ever catch on because so much of it, is abstracted away from the user, which in a way that I think is totally unnecessary. So here's another rule. Your house size is defined as the number of number of values in the fields array, right? Say how many times your little squares on your farm, how many times they're equal to a house square, right? Then like maybe you have like some kind of delta that happens every time there's like a time tick or something. I'm just making up syntax here, but if you're using the oven, it'll increase. If your amount of grains, if you're using the oven, it will decrease. The number of goblins you have, the number of the immigration of goblins to your fields is directly proportional to how much pumpkin patches you have. Because goblins love to come and hunt pumpkin patches. I'm actually going to... It's very important that I get this right, okay? If you have, 4. So like 4 pumpkin patches, you're going to start getting goblins, but it might be worth it. Anyway, and then your score is, of course, like based on a formula. And then, so besides like, so games are a use case for this. Like, like mathematics is a use case for this. But then also things like user interfaces. Like there's a thing called reactive UI that actually works quite a bit like this, where you'll like define something as being like, Twitter, for example, will have like the, Twitter tweet limit dial, right? Dial value will be equal to like, will be defined as being, why can't I type? Tweet char count divided by 240, right? Except they do this in JavaScript, and so there's like a thing that's like, it's actually like they have a, can't remember how they might do it. Like in the C# world, it would be something like, it would be, what would it be called? It'd be called like, observable. Is that what it would be called? I have some code actually for this lying around. Let me see if I can. Yeah, whatever. There's something like observable, like tweet char count. And then this is like a thing that like can be updated but also signals when it's updated. Very strange. Anyway. What if instead of having this goofy code, you could just have the regular code? Wowee. This is not actually real generated code. This is just this is a flight of fancy for me. This would be very nice. Like, somebody could go and, have an abstractly defined game, and then, later on when the bugs are starting to appear, you can just go, get out of here. Get out of here. And then, we've got game code here that we can actually work with. Okay. There's some other, then, I think about that, and then I think also, like, why not always have, well, I think about that, and then I also think about, like, some of the uses I've had for, this inline metaprogramming stuff. And I think, why shouldn't it always be this way, where I have, I have abstract terse code and it, written up in some like visually distinguishable way, and then I have the I have super comprehensible but long-winded code down here. And that'd be super nice. And so, this might, I hope what would be even better than this, like, becoming a common tool that people use, would be a common tool that, like, gets, it'd be a common functionality of an IDE. For example, this is just a little thing I made in Paint or whatever, right? So like a thing in C# is you have an event, and you also have like lambdas, and someone who's new to it, someone who's new to C#, or someone who hasn't like picked up the 500-page textbook about C#, or someone who is like your boss, and like didn't, isn't quite trusting of all the new C# features and wants you to, be careful about what kind of new stuff you're using. It'd be very nice if an IDE, just like how you can view disassembly. Let me pull up a screenshot of that actually. Pull up a screenshot there of visual, because I'm not positive everybody has seen this. Studio View assembly. Okay, where are we going here? Okay, so like Visual C++. You can like go and okay, there we go. All right, but yeah, like you can view disassembly. Like it surrounds your code and it's like an explainer of it. And just like that, it'd be nice if there was always an explainer of whatever abstract feature of a programming language you're using, you know, viewable from your IDE. So in the case of like taking an event and you're subscribing to it with a lambda function that is like capturing, so like I is defined up here, it's getting captured inside of this lambda, which means it's becoming internal state of an invisible class. Like, just provide the users with some way to see all of that. Okay. I guess that's my talk. I mean, do people have questions? Do people want to see me do anything cool? All right, somebody asks me, in my game example, wouldn't it be better off to have a specialized graphical editor instead of doing that in text form? Sure. But, you know, why, if you're doing that in text form, then, you know, you also might want to have that get converted into code. Right? I don't know. Might actually, you know, stuff like that actually might be, I'm not totally opposed to it being, graphically edited. But yeah, you could, no, that'd be sort of a fun, a cool thing is a lot of things like Unreal Engine will have you, I'm going to draw a little doodle of what a game engines will do is they'll have you be able to like use some kind of like, behavior graph. So you've got like, guess you're going to see my awesome design skills. Width 8. Okay, so we've got like boxes here. We've got like, you know, run. We've got like jump, and then you've got like oh wait, before you jump, you've got the wind up to you've got knees bent, and then you've got like what's the thing? What's it called when you do a cool landing? Cool landing. And then you've got grab ledge. Okay, but anyway, yeah. Thank you. These are awesome boxes. But yeah, so like a lot of game engines, you know, they'll have this stuff get laid out like this, and maybe that's easier for everybody to edit stuff this way. Perfect. We've got a behavior graph here, because you never go directly from running to jumping. Oh, you can cancel your wound up jump, and you can bunny hop, and that is and then can go from grabbing the ledge back to running, and also you can go back to jumping. No, you can go back to doing a... Oh, man, I messed it up. Crap. Okay. I'm sorry, everybody. I'm not a good designer. Just forget it. Okay, anyway. But that sort of thing could get converted into code. And that would be really nice. That would be way nicer than, because normally when you're like, when you end up in that sort of situation and something is going wrong with the behavior code that got written, you have to be like looking at like you're looking at code that looks like this, like var node equals node processor dot get next node, and you've got like node dot, you've got like previous node dot selected edge, you know, and you have to be like hovering over it to even figure out like what part of the graph you're in. Whereas what you could instead be in is you could instead be in a function that, you know, looks like, you know, case jumping. That would be nice. Anyway. Okay. I'm going to go ahead. I really like that visual editing example. I mean, yeah, I don't know if there's cases of graphs getting transcompiled into code, but that'd be very nice. Somebody's got a question for me. Somebody's got a real hardball for me, alright? Somebody's going to ask me a question and really make me sweat. Oh. Somebody asks, what languages does this thing make? This thing makes any languages you darned well want. Yeah. I don't actually have a good demo of it doing that right yet, though. But I have, like, generated HTML. You can generate Lua. You can generate shader code. You can generate any old darn thing. However, the eval function only works with C#. So, be aware of that. Alright. I guess that's everything then. Oh, generate XAML? Yeah, no, that's an excellent idea. Excellent idea. I think, yeah. Or actually, like, if you're using WPF, it's very annoying to, like, hook up, it's like things called data bindings, and you have to, like, actually, WPF is WPF is sort of in the same camp as this declarative stuff. And it's really, really syntactically clumsy. Well, that's a situation where code generation would be really nice. Unfortunately, I don't know if this will be anything more than a proof of concept, though, because of the execution speed, and it might be. Maybe I should just do it in Python. Wah wah.
It is a Python program?
No, it's a C# program. But the one that I use on my real project is a Python version, and the only difference is that it does not have the eval in it. And I guess the reason I coded it in C# was because I knew I have to do like new parser stuff in order to support some of the features that I wanted to support. Maybe I'll just add it on top of the existing Python program. Oh no, you can't. That's stupid. What am I thinking? You can't eval. Okay, never mind. That's not going to work, but alright. But yes, what's the question?
So I'm working on a, pretty much it's a virtual reality circuit game.
Mm-hmm.
And one feature I wanted to build in later was pretty much combining circuits and then simplifying I pretty much wanted to build truth tables, but at the same time it'd be nice if I can kind of convert it into code.
So you've got circuits. Like,
right.
Yeah, man, you should just hand that off to a compiler.
Well, right. I could do that too. Okay. I mean, I'm more of they're building the circuits in virtual reality, but then I want to be able to compress the circuit into a different node that they can then physically move around later.
Okay, yeah.
So that it pretty much compiles into one script.
Oh, okay, yeah. I
know that's kind of big. Sorry.
No, it's not. It's not. That doesn't seem. I mean, So do you have a script-based representation of the circuit right now at any time?
I have a script representation of nodes that connect to each other, and they have like a calculation function, and it calculates based on the functionality. Like you have an AND, you have a NOT gate, you have an OR gate, that sort of thing.
Oh, I see. Okay.
So I wanted to be able to compress it so it's one node.
Oh.
So someone could save that and then use that later on a different circuit, pretty much.
Yeah, you should look into like Prolog, which is really kind of based around that sort of stuff. And it's something that I actually know very little about. I'm really all about that imperative programming. Any other questions? Okay. Oh, okay. Somebody's asking me if I rendered that beautiful wallpaper. No, I just looked up. Mandelbrot wallpaper. I think it's called Mandelbulb. Yeah. I do love me my Mandelbrot, though. Whenever somebody sees my wallpaper, they can totally tell that I'm just doing acid all the time. I'm just always taking drugs.